Similar polygons. All right, so we did some application problems yesterday, so you've already seen a lot of the applications of similarity. Here are just some pictures of it. I guess those formations are similar. So with similarity, you can enlarge something like a dilation, or you can shrink it. So when someone's painting a mural, usually they paint it on a little sheet of paper and then they enlarge it and make it bigger by a certain scale factor. And then conversely, if someone's making like a dollhouse, they're going to take a real house of some sort and they're going to scale it down to make the dollhouse with some sort of scale factor. If you don't use a scale factor, then your chair will look weird in the dollhouse living room because the chair will be too big for the room. So you need a scale. You need some sort of scale factor or scaling. I like the picture at the bottom right because that is how they test like planes. They put it in that little wind tunnel, and this plane is a model of a real plane. So they test it and they see how is this going to react when it's stuck in these kind of wind conditions. So if they didn't make that plane similar to the real plane, then all of their testing would be in vain because that plane would react differently than the real one would in a real world situation. So they would need to make that plane exactly similar to the real plane that's going to fly in the air so they can test it out and see if it's going to perform well against whatever weather conditions it comes upon. Cool. So, two polygons are similar. This is the biggest part of this whole day. These two things that I'm about to reveal in these two boxes are almost the only thing you need to walk away with today. Now, when we were in the congruent triangles unit or congruent figures unit, we use this symbol to mean congruent. This unit is all about similarity. So it's not congruent figures, although congruent figures are similar. It's not congruent figures, it's similar figures. And the symbol we use for similar is simply the tilde or the squiggly or whatever you want to call it. It's not a technical term. So two polygons are similar if blank. What do you think? What do you think would make two polygons similar? What's true about two similar polygons? Oh, it's see-through. You already can tell? I can't tell on my screen. Good for you. If they are the same shape, yes. If the corresponding angles are congruent, yes. That's funny. I can't see it on my screen. That's interesting. It's completely white to me. But it shows up on your screen. Okay. Good to know. So, they are similar if. Dun, dun, dun. There we go. The corresponding angles are congruent and the ratios of the lengths of the corresponding sides are equal. Instead, I like to say the angles, here's the shorthand. The angles have got to be congruent and the sides have got to be proportional. Angles congruent, sides proportional. That's what I want you to walk away with. Angles congruent, sides proportional. Angles congruent, sides proportional. Angles congruent, sides proportional. Say that 10 times fast. So, congruent figures are the same size, the same shape. Similar figures are the same shape, but they're different sizes. So, when we were in the transformations unit and we were doing dilations, we were creating similar figures. We were growing or shrinking the figure by a certain scale factor. All right, you have that down? Angles congruent, sides proportional. So the ratios being equal is the same as saying the sides are proportional. Ratios being equal means they're forming a proportion. So we kind of have our bases covered when we say the sides are proportional. I'm going to move on. All right, so anytime you are creating a dilation or you're creating a similar figure, there will be a scale factor. This number will transform your original figure to your image. And that scale factor will work on every single side. No matter what part of the figure you look at, you're going to use the same scale factor or else your resulting image is not similar. So the scale factor is the ratio that will transform the first to the second. How do we find the scale factor? We always take a number from the second and put it over a number from the first. second over first. So this is the other thing that you need to walk away with today. Second over first, second over first, second over first. That's how you're going to find your scale factor. A number from the second figure over a number from the first figure. If you do it backwards, you'll be writing down the reciprocal of the scale factor. So we want to be careful not to go backwards. We want to do second over first to get our true scale factor. Okay? So, Hot Wheels. Who's ever played with Hot Wheels before? Or another product by a different manufacturer that's the same thing? Right? Okay, super fun. So, when they make Hot Wheels, they usually model it off of a real car out there in the real world. So they take a car and they're going to scale it down, but they want it to look realistic. So they're going to scale it down with a certain scale factor. They're going to scale all the pieces proportionally. Without using the internet, don't use the internet, guess what you think the scale factor is. How much smaller is a Hot Wheels car than the real thing? The slide is pretty old, so that car is actually quite a few years old. It's not the new greatest thing anymore. 100 times smaller, 300 times smaller, 150 times smaller. I think y'all are a little too big. Yeah, it's like guessing M&Ms in a jar. 75, 75. Wait, you said you could see through the boxes, so you can already see the answer. Can you see it already, Helaman? So you can't see through these boxes? Not this one? Okay. All right. It's in the 60s. Pi. You're funny. That's not enough at all. All right, so the scale factor is 1 to 64. 1 to 64. So that the real car is 64 times bigger than the Hot Wheels car. Yay! All right, let's try finding the scale factor when I give you two similar figures. So we are going to assume, we have to assume, these figures are similar. So that's the disclaimer. These are similar figures. So everyone write down on their paper the scale factor for A. Go. Okay, you should have it. On the count of 3, type the scale factor for A. 1, 2, 3, type it. Okay, now we need to be careful, guys, because a scale factor is a number. It's a number, and it's not a ratio. And I know that's confusing. Did I have it as a ratio on this page? I sure did, didn't I? Scale factor. Okay, so when I do ask you on a worksheet or a quiz what the scale factor is, I do want you to write it as a fraction. I want you to choose that form of the ratio so it's more like a number. Okay? So the scale factor of this one would be second over first. Second over first. And that's going to reduce to 3/2. So our scale factor is 3/2 or 1.5. Because there are a few questions, some of those district questions on the test where you'll see it as a decimal. Okay? So 3/2 or 1.5. The scale factor is not 2/3 because our figure is getting bigger. Do you remember that from dilations? If it's an enlargement, our scale factor is going to be greater than 1, very good. And if it's a reduction, our scale factor is going to be between 0 and 1. We're not really going to deal with negative scale factors, so we're going to be between 0 and infinity. Okay. B, be careful as to which way the arrow is pointing. Be careful, that is an enlargement. So you want to choose the scale factor that's greater than 1. It's an enlargement. It's an enlargement, so your scale factor needs to be greater than 1. Very good. 4, second over first. This is our second figure, this is our first figure. So we're going to do second over first. Or we could have done second over first. Either way, your answer is 4. Scale factor is 4. So that second heart is quadruple our first heart. Okay? Last one, scale factor. That's a reduction. It's getting smaller. So you want your scale factor to be less than 1. You want your scale factor to be less than 1. So second over first. Second over first. Second over first, second over first. Let's move on. Quadrilateral math is similar to quadrilateral kids. Math is similar to kids. Find the following. Find the scale factor. Find the length of ds. Find the measure of angle t, and find the measure of angle k. I don't know why there's not an equal sign there. What happened to the equal sign? Boop. So let me call on names. Jenny, write us the scale factor. Minjung, write us ds. Austin, angle t. And Quan, angle k. $50, okay. Math to kids. This is the first and the second. It's always listed in order. Angle K is 90. No, remember when we have that M for measure, we don't have to put degrees. That's being redundant. It's weird to not put a degree symbol. I understand. But you don't need it when there's the M. All right, 6/5. Okay, but we're getting smaller, so it needs to be a reduction. Math to kids, math to kids. Second over first, second over first. Second over first, kids over math. Okay. And did we get DS yet? I think that was Minjung. Minjung. Did you get number 6? Or, sorry, did you get DS? Did you already type it? I missed it. It got lost. Okay, yes, 15. All right, so you've got a couple of options when you're finding DS. You can use the scale factor if you want. So you can say, oh, okay, well, this number goes with this number. So I can take my figure and I can multiply it by my scale factor, and I end up with my new side. Because that's what you do with scale factors. You multiply them. If you didn't want to do that, you could set up a proportion. You could say, and it doesn't matter which way you go. You could say 6 is to 5 as 18 is to X. Or you could have done the other way. You could have said 5 is to 6 as X is to 18. And you could have cross-multiplied. So when you're looking for a missing side, yes, Tahani, you always simplify your answers, always. So when you're looking for a missing side, you can either multiply by the scale factor or set up a proportion. Next one, solve for X. I'm going to give you a minute to think about it without me talking. 100. So when we're solving for missing sides, ooh, I need to give y'all time to take your quiz. When we're solving for missing sides, we set up a proportion. So we could say, if we wanted to, we could say 3 is to 12 as, we don't have the thing that goes with x. So we're going to need to do Pythagorean Theorem. But you might remember, that's a Pythagorean triple, 3, 4, 5. But if you didn't remember that, you can do 3 squared plus 4 squared equals blank squared. You're going to get 25, so you'll take the square root of 25. So that's 5. So you could say 3 is to 12 as 5 is to x. And you can cross multiply. 5 times 12, 60. 60 divided by 3, 20. So the answer is 20. The hypotenuse is 20. How many do we have left? Woo, buddy. Okay. Let's go quickly. The two tablets are similar. What is the perimeter of the larger tablet? So we're just going to simply set up a proportion if you want to. You can do scale factor if you'd rather. 10 is to 14 as 7 is to x. So we're going to do 7 times 14 divided by 10. And we're going to get 9.8. But be careful, read your problem. It's asking for the perimeter of the larger tablet. So we're going to do 14 times 2 plus 9.8 times 2. So the perimeter would be 47.6 inches. Always put your units on word problems. Good? Can I move on? Next problem. The length of each side of these equilateral decagons is given. What is the scale factor from star to star? This is going to be our last one. Calculator? Are you asking a question, Yeji? Okay. You already found it, George? What did we learn today? One of the two things we learned today was second over first. So you have way too much information here. You pick any two stars you feel like. I'm going to pick the whole numbers. You pick any two stars you feel like, and you put second over first. So the scale factor is 5/6. The scale factor is 5/6. Now we need to find the length of the smallest star. So we need to take this guy and we need to multiply it by our scale factor, because that's what's happening. This times 5/6 is that. 7.2 times 5/6 is 6. That doesn't look right. Okay, but it is. So now we just need to multiply by 5/6. 25/6, very good. And if you were doing multiple choice and it were a decimal, you could pick a decimal. We could round it to 4.2. All right? I'm going to give you the rest of class to take your quiz. I will post the Google form in the chat.